Behind the vigorous development of the modern aviation industry, the air traffic control seat console, as a key facility for ensuring air traffic order and flight safety, has undergone tremendous changes from simple to complex, and from traditional to intelligent. This transformation is not only a vivid manifestation of technological progress, but also reflects the aviation industry's unremitting pursuit of safety, efficiency, and intelligent management. Early air traffic control seat consoles. In the early days of the development of the aviation industry, the air traffic control seat console was rather rudimentary. At that time, the number of aircraft was small and the flight routes were relatively simple. Controllers mainly relied on visual observation and simple radio equipment to direct the aircraft. The console might merely be a table with an old-fashioned radio transceiver placed on it, a blackboard for recording the position and status of the aircraft, and some simple pen and paper for recording information. At that time, the functions of radio equipment were limited and the signal quality was unstable. The communication between controllers and pilots was often disrupted. Moreover, due to the lack of effective surveillance means, it is difficult for controllers to accurately grasp the real-time position and altitude of the aircraft, and they can only make rough judgments through the reports of the pilots. In this case, the difficulty of air traffic control work is relatively high and the security risks are also relatively high. Changes after the introduction of radar technology. With the emergence of radar technology, the air traffic control seat console has undergone its first major transformation. Radar can detect the position, altitude, speed and other information of the aircraft in real time and display these data on the monitor on the console. This enables controllers to grasp the dynamics of air traffic more accurately, greatly improving the efficiency and safety of control work. The new console is equipped with radar displays, which can graphically present the flight trajectory and position information of the aircraft. Controllers can perform operations such as zooming in, zooming out and panning on radar data by operating the keyboard and mouse, so as to observe the situation of the aircraft more clearly. Meanwhile, in order to cooperate with the use of the radar system, some auxiliary devices have also been added to the console, such as flight progress sheet printers, data recorders, etc., for recording and managing flight information. The application of radar technology not only enhances the accuracy of control but also enables air traffic control to handle more complex air traffic situations. The number of aircraft is constantly increasing, and the flight routes are becoming denser. The radar system helps controllers effectively manage the air traffic flow, reducing the occurrence of flight delays and conflicts. 3. Integration of computer technology and automation systems. Since the 1970s, the rapid development of computer technology has profoundly changed the appearance of air traffic control seat consoles. Computers have been introduced into the air traffic control system, achieving many automated functions. Controllers can quickly query flight information, formulate flight plans, conduct conflict detection, etc., through the computer system, which greatly reduces the workload. The computer monitor on the console has replaced some traditional dashboards and indicators, displaying various information in a digital way. Meanwhile, the computer system has also been integrated with the radar system, communication system, etc., achieving automatic processing and sharing of data. For example, when an aircraft enters the control area, the computer system can automatically identify it and display the relevant information on the console, eliminating the need for controllers to manually record and input. The application of the automation system also includes functions such as automatic flight process tracking and automatic alarm. When abnormal situations occur in the aircraft, such as deviation from the flight path or abnormal altitude, the system can promptly issue an alarm to remind the controller to take corresponding measures. The realization of these automated functions has further enhanced the efficiency and safety of air traffic control. 4. Intelligent console in the information age. Entering the 21st century, with the rapid development of information technology, air traffic control seat consoles have entered the intelligent era. The intelligent console integrates the advanced sensor technology, big data analysis technology, artificial intelligence technology, EPC, and is capable of achieving more intelligent and efficient control operations. The application of sensor technology enables the console to obtain more information in real time, such as meteorological data, aircraft performance data, EPC. These data are transmitted to the console via the network and integrated and analyzed with other information to provide controllers with more comprehensive decision support. For example, when encountering bad weather, the system can automatically assess flight risks based on meteorological data and aircraft performance data, and provide reasonable flight suggestions for controllers. Big data analysis technology can mine and analyze massive aviation data to discover potential patterns and problems. Through the analysis of historical flight data, weather data, flight delay data, EPC, the control department can optimize route planning, adjust flight schedules, and improve the overall operational efficiency of air traffic. Meanwhile, big data analysis can also help controllers better predict and deal with problems such as air traffic congestion. The application of artificial intelligence technology enables the console to achieve some autonomous decision-making functions. For instance, some intelligent control consoles can automatically identify the flight patterns and intentions of aircraft through machine learning algorithms, predict the aircraft's actions in advance, and automatically generate corresponding control instructions. Although these autonomous decision-making functions still need to operate under the supervision of controllers at present, they provide a new direction for the future development of air traffic control. Future outlook. The degree of intelligence and autonomy has been continuously enhanced. More advanced artificial intelligence applications. In the future, artificial intelligence will play a more core role in the air traffic control console. Machine learning algorithms will be continuously optimized to predict the flight trajectory of aircraft more accurately and identify potential conflicts and abnormal situations. For example, through the learning of a large amount of historical data, the system can accurately predict in advance the possible mechanical failures or other emergencies of the aircraft and gain more response time for the controllers. Enhanced autonomous decision-making ability. As technology matures, the autonomous decision-making function of the console will gradually increase. In some conventional control scenarios, such as when the aircraft flies along the predetermined route and no abnormal situations occur, the console can automatically issue standard control instructions to reduce the workload of the controllers. Meanwhile, when encountering complex situations, the console can also provide more intelligent decision-making suggestions and even assist controllers in emergency response to a certain extent. Integrate more advanced technologies. Virtual reality VR and augmented reality AR technologies. VR and AR technologies will provide controllers with a more immersive and intuitive working experience. Through VR technology, controllers can experience the overall situation of air traffic as if they were in the air directing traffic. AR technology can superimpose virtual information onto real scenes. For instance, on the console, real-time data of the aircraft, flight plans, meteorological information, EPC, can be displayed through AR, enabling controllers to obtain and process information more conveniently and improving work efficiency and accuracy. Internet of Things IoT technology. IoT technology will further expand the information acquisition channels of the console. In addition to traditional data sources such as radar and meteorology, future consoles will be able to connect to more Internet of Things devices, such as sensors on airport runways and real-time monitoring equipment on aircraft. These devices can upload various data in real time, such as the condition of the runway and the maintenance information of the aircraft, providing controllers with more comprehensive decision-making basis. Expansion of management capabilities for new types of aircraft. Unmanned aerial vehicle UAV management. With the rapid development of the UAV industry, the application of UAVs in logistics, mapping, aerial photography, and other fields is becoming increasingly widespread. The future air traffic control console needs to have the ability to effectively manage unmanned aerial vehicles UAVs, including real-time monitoring of the flight status of UAVs, planning their flight routes, and avoiding conflicts with manned aircraft. This will prompt the console to develop a dedicated unmanned aerial vehicle control module for seamless integration with the existing air traffic control system. Electric aircraft and new types of aircraft. Electric aircraft, vertical takeoff and landing aircraft, and other new types of aircraft will also gradually enter the market. These aircraft have different flight characteristics and technical requirements. The control console needs to adapt to these changes and have the capabilities of parameter monitoring, performance evaluation, and control command for new types of aircraft. For example, the battery power monitoring and endurance assessment of the electric aircraft will become one of the important factors in regulatory decisions. Globalization and collaborative development. International information sharing and collaborative control. With the continuous integration of the global aviation industry, international cooperation in air traffic control will become even closer. The future air traffic control seat console will have a more powerful international information sharing capability, be able to exchange data in real time with control centers around the world, and achieve seamless control of cross-border flights. For instance, by establishing a unified international air traffic control data platform, controllers from different countries can share information such as the real-time location and flight plans of aircraft, thereby enhancing the operational efficiency and safety of international flights. Multi-departmental collaborative control. In addition to the collaboration with the International Control Center, the future console will also enhance the collaborative work with multiple relevant departments such as airport operations, airlines, and meteorological departments. For example, share runway usage, boarding gate allocation information, etc. in real time with the airport operation department to better coordinate the ground operation of flights, share passenger information, luggage information, etc. of flights with airlines to provide support for handling special circumstances. Work closely with the meteorological department to obtain accurate weather forecasts and real-time meteorological data in a timely manner and optimize the flight routes and takeoff and landing times of flights. The changes of the air traffic control seat console have witnessed the development process of the aviation industry. From the early rudimentary equipment to today's intelligent control consoles, every transformation has driven the advancement of air traffic control technology, enhancing aviation safety and operational efficiency. In the future, with the continuous innovation and development of technology, the air traffic control seat console will continue to play an important role and safeguard the prosperous development of the aviation industry. We have every reason to believe that future air traffic control will be more intelligent, efficient, and safe, providing more reliable guarantees for people's travel and the development of the economy and society.